Alright, pre-calc, this is P.3, and actually I should have here, this is part 2. So we're going to look at the rational exponents of section 3 now from the prerequisite chapter. So we're going to talk about simplifying the nth roots and then what a rational exponent means. Again, prerequisite, so it's going to be all a review of stuff you guys have all seen before. So when we talk about something with the nth root, what we mean is we're taking something like a square root except for the index, and this value right here is called the index, is going to be some other number than 2. So it could be the third root of a, the 10th root of a, and that equals b, which just means that if we take b raised to that index, we would get a. Much like if you said the square root of some number, or let's say of b, that would just mean that it is, whatever that number is, squared. Okay, so if n is even, meaning our index is even, then like we talked about in class the other day, a and b have to be greater than 0 or positive. If the index is odd, then it doesn't matter what a and b are. They can be any real number, any decimal, as long as they are not imaginary. And finally, stuff we talked about in the last video from part 1 from section 3, the product and the quotient rules for the roots apply. And we can even say not square roots here, but for the nth, roots are still going to apply. Meaning we can separate them or put them together as needed to simplify things. Okay, so one thing, if we talk about the cube root of 216, you put that in your calculator, you would see that that means we would get 6. And that's because 6 cubed is equal to 216. Okay, if we take the 5th root of 96, well then we're going to get some ugly decimal, 2.49. Okay, so when we are working with rational exponents, so we're moving on now to rational exponents, what that means, and this is an exponent that's a fraction, kind of like you see in the example here, the numerator is going to be your exponent, meaning you raise it to that power, but the denominator here is going to be the radical's index. So it would look something like this: a to the m over n equals the nth root of a to the m power. And you can switch the way we write this too. We could say the nth root of a all raised to the m power as well. So what we have here is then the cube root of 27 being raised to the 4th power. In this case, it's easier to take the cube root first because we know the cube root of 27 is 3, and then we're going to raise that value to the 4th power, and 3 to the 4th power is 81. So that would be the simplification of 27 to the 4/3. Okay, and that is it for this, for part 2 of P.3, real short, real quick, and we will see you next time. We're going to talk some more in groups about rational exponents and trying to create some that we can simplify partially. Okay, see you next time.